Hi, my name is Moriah Munroe, and I like cookies. Do you like cookies? I'm gonna assume you said yes, since most people do. Well, my question was whether or not, originally, it was if you could make the perfect cookie. But then, when my younger siblings barged into my room while I was pondering that, I realized my perfect cookie, optimal cookie, would not be the same as my younger siblings' optimal cookies. So, I'm going to give you a bit of background. I'm the oldest of four, and I have three younger siblings. All of them are girls. They all really like a lot of sugar. I realized that theirs would probably be different, so I decided to try to figure out if I could figure out, everybody else's perfect cookie. So, my dad and I did some research for this science fair topic, and we discovered a useful axis from the cinnamon challenge, the spicy axis. However, I realized that we could not have test subjects falling dead over the heat. So we had to change from the spice axis, and as such, a different recipe. We were originally going to be using my dad's pumpkin nut habanero recipe. It's his personal favorite. However, we changed to a whiskey bacon maple cookie, and while it's difficult to make, it is delicious. I'm just going to say that. So we found two more axes with that recipe, the savory axis and sweet axis. We expected that older boys would prefer something more savory salty, so like more bacon and salt. Younger boys would prefer moderately savory, so something a bit like, less bacon, obviously. Younger girls would also likely prefer more sweet, as I said previously, and older girls would prefer moderately sweet. So, how would we test that out? I need to take a moment to show you how we find the optimal cookie recipe area using just a few tests. This is a map with infinite cookies. Infinite cookie recipes. Each and every point is a recipe. It's kind of like Candyland. Just, cookies. The center is the original recipe. All of this little heart thingy, or dot, if you would prefer to call it, is basically your perfectly optimal recipe. You have no idea where it is, though. So using these numbered points are samples that we use to find your favorite area. Something closer to your favorite tastes way better than something way out distant in the boonies. If we get to the right area using only the tests, that shows how the method works. Here is where I will ask you which one tastes better, aka which of the two samples is closer to your ideal, and we'll write down the answer. Which of one or two is better? Two, you say. Which of one or three is better? Three, yes. One or four? Four sounds correct. One or five? Five, okay. Two or three? Three. Two or four? Two, yes. Two or five? Five sounds about correct. Three or four? Three. Three or five? Three, yes. Three or four or five? Four, five, yes. This is how we will figure out your favorite cookie, basically. So we're going to actually have to bring a bit of math into this. Add 2 plus 3 plus 4. That's basically the same as 3 times 3, or 3 squared, which is 9.
Add the second three preferences. 5, 3, and 2. 5 times 2 is 10. And the last four preferences, which would be 5 plus 3 plus 3 plus 5, or 16. Then you will assemble the lookup in the following. You will assemble the following in these slots down here. So 9, 10, 16. So let's see if we can actually find this. These are all the numbers that you could potentially end up with altogether. So first come finding all the 9s, then all the 10s, and finally all the 16s. Now, where's the one line where all of these meet? That'd be number 12, or line L. It is in region L. Now that we worked through it end to end, I can show you what I did with it. It does in fact work. We discovered where the heart perfect recipe was using only tests. We can show or rediscover a best recipe using just these tests.
So, how would we test that out? We got 5 recipes. Well, 5 variations of the same recipe. We were originally going to do 9. But then we had a gross reality check and realized that would not work. Ever. We're doing paired tests. A-B testing, it's called. It's like, would you prefer A or B after you've tasted them? So, with paired tests, 9 samples would mean you would be sitting in there tasting the same variations of a cookie 36 times.
Now, for all of these tests, imagine that instead of having to take 10, as you can see in the beautiful column over here, you had to take 36. That's what having 9 would give us. 9 different cookie samples equals 36 tests, which is a really bad idea.
A bit of detail in this one, but basically, why not do OAT one at a time testing versus A/B testing? Like, what's the difference between them? Why would you do A/B testing? That's because it gets you better information. Instead of giving them, all right, you have 10 cookies here, choose your favorite, and go. That doesn't work. You have to do, all right, so would you prefer A or B? B or C? C or D? And so on. This right here is a paper fortune teller. No, just kidding, it's not, but that's what it looks like when it's unfolded. Each of these little triangles is a different recipe. Our information lined up very well with our hypothesis. Basically, we had assumed that it would be either both older or both younger. That was incorrect. The boys in the class chose that of a younger child. Basically, they preferred the moderately savory, as you can see on the graph. Savory, sweet. Boys and girls. The girls preferred less sweet and more savory, more like an older girl. So, basically, boys' tastes age slower than girls. Some of the next steps we could do are like getting more test subjects, more of a variety, so like grandma and then a small child as well. Another thing is more cookies, like there are only 5 here. Having 9 would give us better information as well. So yeah, any questions?